Welcome to Chapter 16, Equilibrium. Today is the day that we actually cover introductory economics. So all the topics that you recall from introductory micro, now that we've laid the theoretical foundation for each part of it, we can describe it in greater detail and with greater specificity. So first of all, supply. We're going to actually kick the can down the road a little bit with supply. We're going to find in the next section of the course that the supply curve represents the minimum prices firms are willing to pay to produce and sell an additional unit of the good. And demand, from the theory that we've developed so far in the course, we know that each discrete point on the demand curve represents the reservation price of some consumer. It's the highest price the consumer is willing to pay to purchase and consume an additional unit of the good. Varian explains to us that price and output are simultaneously determined with two notable exceptions. The first exception would be if we have a vertical supply curve. What this means is that in the very short run, there is a given quantity of goods and services that are available to sell. Higher prices cannot bring additional units into the marketplace, and the seller has to move the goods regardless of how small the selling price becomes. A classic example of this perhaps might be cut flowers, particularly right before Valentine's Day. No matter how high the price becomes, the flowers that appear at the local flower shop have been shipped weeks ago, largely from South America. And higher prices are not going to bring additional flowers to the marketplace. And the flowers that are available for sale must be moved. If they're not, they become worthless. What this means then is that prices rise to ration the given supply to the consumers that value it the most. The other, since we're in the theme of love, the other example that I could think of that might perhaps represent a horizontal supply curve might be the De Beers Diamond Cartel. For the last several decades, 3 or 4 decades, the De Beers Diamond Cartel, which is out of South Africa, controls upwards of 70% of the market for retail gems. And what they've done is they've had a policy of trickling out just enough diamonds to maintain stable prices. Right? So they have several years worth of diamonds on hand, and they adjust the supply in the marketplace to maintain a constant price. So in this case, the horizontal supply curve represents that De Beers is committed to maintaining the current price of diamonds. To compute equilibrium, we have actually two alternatives at our choice. We could set the quantity demanded as given equal to the quantity supplied and solve for equilibrium output. We could alternatively invert these. We could invert the demand curve into inverse demand, which, remember, tells me, given the quantity that's offered for sale, what is the maximum price consumers are willing to pay. And alternatively, we have inverse supply, which represents the same thing. Given the quantity that is in the marketplace, what is the minimum price that suppliers would be willing to accept for this quantity? So one way we could compute equilibrium is by setting the quantity demanded equal to the quantity supplied. It's straightforward algebra, very easy. We're able to derive the equilibrium price, and then we can substitute this equilibrium price of 40 back into either the demand function or the supply function, and we would get the equilibrium quantity sold, which is 60. Equivalently, we could set the price that demanders are willing to pay equal to the price suppliers are willing to receive. And we will get the identical outcome. You'll notice we get the same quantity sold, we get the same price. You might wonder why we're showing both ways. it turns out that it does actually make at least a little bit of difference when it comes to more complicated equilibrium concepts, particularly when we introduce taxes. So in this diagram, I've illustrated a tax of $10 that's collected from suppliers. And you recall from Intro Micro, the way that we illustrate this is we shift the supply curve vertically up by $10, so that now the gap between the price that suppliers receive and the price that demanders pay is the tax that goes to the government, and that is $10 in this case. So we could model this very easily with our inverse demand and inverse supply functions. So translating the picture into math, we could say the price demanders pay is equal to the price suppliers receive plus the tax rate. And in the next line, I substitute in the inverse demand and inverse supply functions and the numeric value of the tax. So now we get the equilibrium quantity sold, and we get the price that demanders pay and the price that suppliers receive. We could actually compute equilibrium by using demand and supply functions rather than inverse demand and inverse supply. The key is this third piece of information almost directly above my image in this slide, that the price demanders pay is equal to the price suppliers receive plus $10. To get equilibrium, what we need to do then is re-express the quantity demanded as a function of the price suppliers receive. Normally, as we have in the first line of math, the demand function, the quantity that demanders pay, is listed in terms of the price that demanders pay. But notice that when I go to get equilibrium, I want to express quantity demanded as a function of the price that suppliers receive. So I know my demand function is 100 minus the price demanders pay, and then through substitution, the price that demanders pay in the second line is equal to the price suppliers receive plus 10. And we can go through the math. We will get the same price that suppliers receive, the same price that demanders pay, and the same equilibrium quantity. Literally, they're the same. I would counsel you to use whichever methodology makes more sense to you. Both of them will get you to the same place. For some odd reason, the first methodology we went through makes more sense to me, but this one works just as well. They're actually letter identical. Okay. So you remember again from Intro Micro, a very important point was that when we collect taxes from a marketplace, it actually makes absolutely no difference whether we collect the tax from the suppliers or the consumers. It makes no economic difference. Right? So if we collect the tax from suppliers, in the diagram to the far left, we shift the supply curve up vertically by the amount of the tax. If instead we collect the tax from customers, what we would do is we would say we would shift the demand curve vertically down by the amount of the tax. The price demanders pay, the price suppliers receive, and the quantity transacted will be the same. And it's easy to show this with math. I'm not doing it on this slide, but you can see easily how it could be done. Now, in public economics, which actually I teach is one of the electives, this topic of tax incidence is one of great interest to tax economists. And the idea of tax incidence is when you impose a tax in the marketplace, who ends up paying more of it? So in this numeric example we've had so far, where we have the demand function and the supply function is given below, you'll notice that when we imposed a $10 tax, going from the original equilibrium price of 40 after the imposition of the $10 tax, the price suppliers received went down by $3.33. The price that demanders paid went up by $6.67. What we could say then is that the price demanders paid rose by twice as much as the price suppliers received fell. So in essence, this tax fell more upon demanders than it did upon suppliers. It hurt demanders or final customers more than it hurt suppliers. And the question you might ask is why? Well, it turns out one very simple way we could say this is when you look at these demand and supply functions, you'll notice that the slope of the supply function is twice as steep as the slope of the demand function, right? The demand curve slopes down with a slope of -1. The supply curve slopes upward with a slope of -2. If we have a steeper supply curve, what that means then is that when the price rises by a bit, the quantity is going to respond less. The quantity supplied will respond less than the quantity demanded will fall for a same dollar increase in price. The way we can express this more elegantly in public economics is we can find through this classic result that I have at the bottom of the slide. This is due to a very famous paper that came out in the early 80s by Larry Kotlakov and Larry Summers that showed that the change that, so if we differentiate the price suppliers receive with respect to the tax rate and differentiate the price that demanders pay with respect to the tax rate, you find that these changes are a function of the price elasticity of demand and the price elasticity of supply. The punchline that I have at the bottom of the slide is that the less elastic element bears more of the tax. So I'll illustrate this with a few examples. So we think back to Valentine's Day. What if the city government, in an act of abject cruelty, decided to tax cut flowers? So the question is, which element is less elastic? So as we think about this, I claim that the price elasticity of supply is 0, meaning that as we raise prices by 1%, the percentage change in quantity supplied is 0. So in other words, this vertical supply curve implies that if prices were to rise by 1%, the quantity that remains in the marketplace is unchanged. So we have a normal sloping downward sloping demand curve. You recall that as long as we're not at either end point, the price elasticity of demand is some well-defined negative number that's strictly less than 0 and not infinite if we're away from the vertical axis. What that means then is if we substitute in some finite number for the price elasticity of demand and we substitute in 0 for the price elasticity of supply into the formulas that I gave you from the previous slide, what we find is that the change in the price suppliers receive with respect to a change in the tax rate is -1. What that implies then is if the tax rises by $1 on cut flowers, the price that suppliers receive falls by $1. And then, likewise, if we put these values for the price elasticity of supply and the price elasticity of demand into the second formula at the bottom, we have the price elasticity of supply of 0 over 0 minus a negative number. This will be 0. So what this says then is if the government taxed cut flowers, the price that consumers end up paying will not change. It's basically taking the money from your local flower shop or your local grocery store, right? Or more formally, suppliers bear the entire tax. And you can see that if from the picture, if we have the original supply curve in black, if we impose a $1 tax on all bundles of cut flowers, what that does is it shifts the supply curve upward by 1, and that's the red supply curve, which is on top of it. The price that demanders pay remains unchanged. And just reasoning through this, it should be obvious why. It's because that changes in price do not cause any more or less flowers to be available in the marketplace. The quantity is fixed, meaning that the price elasticity of supply is completely inelastic. What if the government taxed diamonds? Well, we have in this case, I mean, we can see from the picture, if the horizontal supply curve shifts up vertically, what this means then is that the price that the diamond cartel, De Beers, receives for a carat diamond remains unchanged. You remember, the reason why we have a horizontal supply curve is that the diamond cartel wanted to maintain stable prices through time. They bleed just enough diamonds onto the market to hold the price constant. If the government imposes a tax upon diamonds, and the diamond cartel still wants the same dollar amount for each diamond sold, that is unchanged. Basically, De Beers gets its desired price, and consumers end up paying the tax. We can see this with the elasticity formulas. In this case, a horizontal supply curve, we have a price elasticity of supply of infinity, meaning that if the price were just a little bit below P sub S, De Beers will not sell any diamonds on the market. And if the price rises by just 1 penny to hit their target price, De Beers is willing to supply as many diamonds as the market wants at their target price. So we get an infinite response for an itty-bitty change in price. And then the price elasticity of demand, again, is some well-defined number, strictly less than 0, but not infinite. So we substitute those values into the elasticity formulas, and what we see is that the derivative of the price suppliers receive with respect to the tax is 0. The derivative of the price demanders pay with respect to the tax is equal to 1, or it approaches 1, meaning that consumers bear the entire tax if the government decides to tax diamonds. What if the government taxes Zocor? So back in chapter 7, I introduced the example that Granny consumes buffet trips to the Golden Corral, and Zocor, which is this anti-cholesterol medication that's supposed to drastically reduce the probability of a heart attack. So I claimed that Granny's doctor wants her to take 1 and only 1 pill per day. And if taking Zocor really does dramatically extend Granny's expected lifetime, her demand for Zocor is going to be vertical. More Zocor does not benefit Granny. She wants 1 and only 1 pill per day, and she's willing to pay any reasonable price for it. So if the government taxed Zocor, you can see from this picture the supply curve shifts vertically up by the amount of the tax, and since Granny needs 1 and only 1 Zocor pill per day, what ends up happening is that Granny will pay the entire tax. We could see that through math. So in this case, the price elasticity of demand is 0, meaning that as the price of Zocor changes, the quantity demanded remains unchanged. And we have some reasonable positive price elasticity of supply. So we substitute in 0 for the price elasticity of demand and know that the price elasticity of supply is some reasonable positive number, and you get 0 over some positive denominator, and the change in the price that suppliers receive, so the drug companies receive, if the tax rises by $1 per pill, is 0. So the price that the manufacturer of Zocor receives is unchanged after the government taxes it. But when we put the elasticities into the formulas for the change in the price Granny pays when the tax goes up, it's 1. So Granny pays the whole tax. One of the other subjects that I hope you remember from Intro Micro is this idea of a deadweight loss that occurs when the government imposes a tax. So if we have a perfectly competitive model left to itself, remember we have producer surplus and consumer surplus. We've talked about consumer surplus so far. That was the difference between the reservation price, or the maximum willingness to pay, and what consumers were willing to pay. So you could imagine from the original price P sub 0, it's the entire upper triangle. And producer surplus is defined in an analogous manner. It's the difference between what firms receive and the minimum they were willing to accept, as represented by the supply curve. So now if the government imposes a tax in this marketplace, what happens then is that you have these 4 boxes, A, B, C, and D, that change what they were. So for instance, A and B, prior to the tax increase, were both consumer surplus. C and D were both producer surplus prior to a tax being imposed. When the tax is imposed, A, which used to be consumer surplus, now goes to the government, right? So the government revenue that's collected is box A plus box C. So the height of that double box is now the tax rate, the tax or the tax per unit times the number of units sold, and A plus C now is government surplus. It's tax revenue that the government collects. Okay, and some of it comes from consumers, some of it comes from producers. But then B and D are deadweight loss. So B used to be well-being that consumers received, and now because those last few units aren't sold, that surplus that used to exist disappears, right? The surplus that used to exist to producers in box D now does not exist as a result of the taxes choking off demand. So box B and box D together are the deadweight loss. That's considered the efficiency costs of taxation, right? So well-being that was destroyed as a result of increased taxes. Now, it turns out, again, a very interesting result from public economics. We can show that the deadweight loss is roughly proportional to the tax rate squared. And we can show this through this simple diagram. So let T be the tax. Okay. The deadweight loss is that triangle. And of course you remember the way that we find the area of a triangle. It's 1/2 base times height. So in this case, the base of the triangle is delta Q, the change in quantity that resulted from the tax increase. And the height of the triangle is the tax itself, T. So if we think about how would I compute the change in quantity as a result of the tax increase, we could use it. This is an old result from graduate economics called the envelope theorem, right? So we can say that the units change in quantity is equal to the partial of demand with respect to the price consumers pay times the derivative of the price demanders pay with respect to the tax times the actual amount of the tax. So what this tells me then is we have this rate. How does demand change as I change taxes by just a little bit, and I multiply that by the actual quantity of the tax? And you'll notice that when I expand this all out, I have t times t, or t squared. So deadweight loss increases in taxes squared. What that means is if I double taxes, deadweight loss quadruples. If I triple taxes, deadweight loss grows ninefold. If I quadruple taxes, deadweight loss rises by 16-fold. So as taxes rise, the efficiency costs of taxation rise in taxes squared. So very important and interesting result. Varian covers quickly at the end of this chapter. He goes into this subject of general versus partial equilibrium. So we've talked about what we've talked about so far in this semester. We've looked at the market for one good in isolation. So we've looked at the price and quantity in a single microeconomic market. That is known to economists as partial equilibrium. But of course, we have thousands and millions of markets operating simultaneously. If we were to model, instead of just a single microeconomic market, all of them together, that is general equilibrium. And to quote our friend Chul Ho, general equilibrium is very hard. It turns out that the next chapter we're going to cover, we're going to go out of order, and after chapter 16, we're going to look at chapter 32, which is exchange. And in exchange, the exchange chapter, we're going to look at a general equilibrium with two goods for sale. So we'll look at general equilibrium in the simplest possible manner to derive basic insight. One of the most powerful theorems of microeconomic theory is the first fundamental welfare theorem of economics. And this is the first fundamental theorem. If there is a perfectly competitive market for each good consumed, there is perfect information. So in other words, all consumers are available, they have knowledge of who's selling goods, who's selling each good at what price. It's costless for firms to enter and exit the marketplace, and there are no external costs or benefits in either production or consumption. Then the equilibrium which emerges will be Pareto efficient. What this means literally is that a perfectly competitive economy left all to itself will go to an efficient allocation of goods and services. Saying that the economic outcome is Pareto efficient means literally that the only way to make one person in the economy better off is to make someone else worse off. That was the Italian economist Pareto's definition of what it means for the distribution system of an economy to be working perfectly. Or if we want to say this in kind of a blunt, crass manner, we could say that an omniscient, benevolent central planner would not be able to engineer a Pareto improvement. So a Pareto improvement would be a situation in which it was possible to reallocate goods and services in such a way to make at least one person better off without harming anyone. So oftentimes the idea of central planning or government intervention in the economy is to make people better off. So the first fundamental welfare theorem says that if the market were perfectly competitive, it's actually not possible to make someone better off without hurting someone else. Now, let me caution that the that the conditions necessary for the first fundamental theorem are very, very strong. And we're going to talk later in the semester about how many times in practice they're violated. But just a few. So the first one, there's a perfectly competitive market for each good consumed. So one good that we consume is air. Is there a market, a perfectly competitive market for air? Right? Perfect information. So what this says is that every consumer has knowledge of every producer and how much they're selling each good for. Now, certainly the internet and smartphones have made information a lot more complete than they were when I was your age, but I would argue that information still isn't perfect, right? Google doesn't know everything. They know close to everything, but not quite everything, right? And then the external costs and benefits, we're going to talk about that when we hit chapter 35 on externalities. So the first fundamental welfare theorem is a tremendous result, very important result, but it may not be particularly applicable. I'll leave it there. Okay. So quizzes, we have an inverse demand function for apples, we have an inverse supply function, and now we have a tax imposed. So the question here is, when the tax is imposed, what will the new quantity of apples sold be? And this is just straightforward math. I expressed to you before that I like to solve these with inverse supply and inverse demand. So here we go. The price demanders pay is equal to the price suppliers receive plus the tax rate. And then it's just simple algebra. We rearrange it. 20 apples are sold. Okay. Problem 2. In a crowded city far away, the civic authorities decided that rents were too high. We have a long-run supply function for 2-room rental apartments and a long-run demand function. And if the local governing authorities impose a price ceiling of 15 crowns per week, but they commit to paying a subsidy to landlords large enough to eliminate the shortage that would exist, how large would the subsidy have to be? And as always, I strongly recommend in problems like this drawing pictures. Drawing pictures is your friend. It'll give you the intuition, and then we'll be able to very easily come up with math to match the intuition. So I have a price ceiling of 15 crowns. I can compute the quantity that would be demanded at 15 crowns, and then what I need to do is figure out the inverse supply. So in other words, if the quantity indicated in this picture is to be produced, what price do landlords need to see? And then the difference between the price that producers must see, or landlords must see, and the price imposed in the marketplace, 15, will be the amount of the subsidy. It's that vertical distance that I've indicated in the graph. So if there were a price ceiling of 15 crowns, 69 apartments would be demanded. And if, so I take the supply function, I invert it, and then I put the 69 apartments that would be rented into the inverse supply function and find out that landlords would demand a price of 27 crowns per week to be willing to offer for rent 69 apartments. So if the government has imposed a price ceiling of 15, 27 is needed, the subsidy must be 12 crowns. Okay, so that'll do it for chapter 16.